In this video, we will learn about the process of melting. So melting is the process where the solid changes into liquid. So we can say that the process in which the solid state of matter changes into liquid state, usually by heating, is called melting or fusion. So we know that by increasing or decreasing the temperature, we can change the state of matter. So if we have a solid state of matter, we can heat it up and it can be converted to liquid. This process is called melting. But this process takes place at a specific temperature. So the temperature at which the solid melts to become the liquid at a particular pressure. So in this case, we will take standard pressure, which is 1 atmospheric pressure. So that will be known as the melting point of that particular solid. So to understand melting of a solid, we have a small activity. So where we will be arranging the apparatus as shown here. We have taken some crushed ice in the beaker and attached a thermometer to it to measure the temperature, and with the help of the Bunsen burner we are going to heat that. So now when we will be heating it, what we will observe that earlier the temperature of ice is 0 degrees Celsius. As we slowly heat the beaker, ice will start to melt. But we will notice that ice has started to melt, but the temperature has not changed. Temperature will remain constant, that is at 0 degrees Celsius, until whole of the ice melts and changes into water. So when whole of the ice melts and changes into water, then we will observe that the temperature starts to rise. So from here we can conclude that the melting point of ice is 0 degree Celsius. So now how this process of melting happens, let us understand that. So in solids, the interparticle forces are strong and particles are held closely. Now when we are heating it, what happens is the particles start to move faster, means their kinetic energy increase, and they start vibrating rapidly, means whatever heat we are providing, it is getting transferred as kinetic energy to the particles. The kinetic energy of the particle increases, and in the case of solid they vibrate, so here they will start vibrating rapidly. Now at a particular temperature, what will happen, as we are continuously heating it, the kinetic energy becomes sufficient to overcome the interparticle forces. So as soon as the kinetic energy is sufficient to overcome the interparticle forces, the particles start to leave their fixed position and they will start moving freely. As a result, they will get converted to liquid, and this temperature will be called the melting point of the solid. For example, we know solid ice melts to liquid water at 0 degrees Celsius. So the melting point of ice is 0 degrees Celsius or 273 Kelvin in Kelvin scale. So actually the melting point of a solid is a measure of force of attraction between the constituent particles, means if strong forces are present between the particles, so it would take us higher amount of temperature to overcome those forces of attraction, means the melting point will be higher. So we can say higher the melting point of solid means stronger the forces of attraction between the constituent particles, and vice versa. So pure solid always have a sharp definite melting point. So melting point can also be used as a criteria for purity of a solid. Now we have observed that the temperature remains constant until all the ice has melted. Now what is the reason behind it? Why does the temperature remains constant during melting? Now we know that temperature of a system is a measure of kinetic energy. So in that activity we have observed that temperature remains constant during the melting of ice even when heat is continued. Only after all the ice has melted, temperature starts to rise. Now the reason is when the substance is changing from solid to liquid state, the heat energy is used up to overcome the forces of attraction. So whatever heat we are supplying after 0 degrees Celsius, after the melting point has reached, all that heat is getting used up to overcome the forces of attraction between the particles. So it is not getting used up, or it is not showing us as the temperature change, because all that heat is used up by the particles. So as the kinetic energy remains unchanged, the temperature also remains constant. After melting is over, the heat supplied increases the kinetic energy of the molecule and the temperature starts rising. So here we can observe that the temperature remains constant up to 0 degrees Celsius until melting of ice completes. After it is completed, again the temperature will start to rise. So this is all about the process of melting. I hope the topic is clear to you. Thank you.